All right, guys. Hey, sorry about the internet connection today. Uh, Total bummer. It was the same all around campus. Um, so, what I wanted to do was just real quickly, and shouldn't take too long here, just about hopefully 10 to 15 minutes or so of your time to be able to go through and kind of fill out the notes here with me as I kind of work through it. Okay. And then tomorrow we can kind of pick up where we left off after this video. Okay. So the first question there, we're looking at the warm up. We were flipping two coins and we wanted to display the outcomes in the charts. All right. So this is what's called a sample space. This is where we are going to show like basically all of the possibilities that could occur. Okay. So when we flip the first coin, the possibilities are either heads or tails, right? The flip sides. And when we flip the second coin, possibility is also heads or tails. So the first question is, what is the probability of a heads up result for flipping the first coin? And what we call this is the probability of occurrence A. And basically what we're calling this is the first coin is occurrence A, the second coin is occurrence B, basically. Okay. So the probability of, let's see, what is the probability of a heads up resulting for flipping the first coin? Okay, well, it's a 50-50 chance, right? It's a 1/2 chance. So we just say the probability is 1/2. All right. So if we were to look at our sample space here, just to kind of fill this in, what we had determined in class is, well, we could flip the first coin and it would be heads, and the second coin and it also be heads. Okay, so one possibility when we flip two coins is heads, heads. We could flip the first coin and get heads, flip the second coin and get tails, okay, which would be different from flipping the first coin and getting tails and flipping the second coin and getting heads, right? So these two are different. This represents the first coin being heads, the second being tails. This represents the first being tails, the second being heads. Or we could flip tails both times, okay? So anyways, for the first one, what is the probability of a heads up result for flipping the first coin? Just 1/2. Okay, B, what is the probability of a tails up result for flipping the second coin? Okay, so the probability of B occurring and it being tails. Okay, so the second coin, basically what this is asking is what is the probability that the second coin that we flip ends up being tails? Okay, well, once again, it's just 1/2. Okay. Now, C is where things get a little bit different. C is asking what is the probability of a heads up result for the first coin flip and a tails up result for the second coin flip? Okay, so what this looks like is, let me make sure you guys can still see this. Let's see. Yep, okay, we're still good. What is the probability of a heads up result? Okay, so what this looks like is what is the probability of A occurring and B occurring? Okay, so what is the probability of a heads up result for the first coin and a tails up result for the second coin? Okay, well, the only place that happens here in our sample is right here. Okay, right here in this guy. Okay, now this is one possibility out of 4 total possibilities, right? There's 4 total possibilities that could result when we flip two coins. That's one possibility. So the probability of flipping a heads on the first coin and then a tails on the second coin, that is going to be 1/4. Okay. Now, there is a formula, and it's in your notes, and this is the formula for ands. Okay. The probability of A multiplied by the probability of B is going to equal the probability of A and B. Okay, now whenever you see and, what you can do is you can take the probability of A and multiply it by the probability of B. Why can you do that? Well, we just proved it here, right? The probability of A occurring and B occurring, it happens right here, right? It's one occurrence out of 4 total occurrences. So that was 1/4. Okay, but if we split this up and we say, what is the probability of A? Well, it was 1/2, right? The probability of A was 1/2. What's the probability of B? Also 1/2. And it just so happens when you're asking, okay, what's the probability of A and B happening together? Well, you can multiply them together and it gives you 1/4 or 25%. Okay. Now D, let me again make sure you guys can still see all this. Okay. Let me go right down over here. Okay, so D, what is the probability of a heads up result for the first coin flip or a tails up result? Okay. So now for this one, ORs are different. Okay, and we're going to talk a little bit more about ORs later on in the next example. Okay, but what this is saying is, what is the probability of A or B? Okay, so the probability of A or B happening, let's see here, that is going to be, let's see if you can get it. Pause it now if you want to see if you can get it on your own. Okay, but it's actually going to be 3/4. Okay, because the probability of A happening, A being we flip the first coin and it's a heads. That happens here and here. Okay. Now, what's the possibility of flipping and getting the second coin as tails? Well, that happens here and here. So that's 3 possibilities out of the 4 total. That's where the 3/4 comes from. Okay. So what we said in class here is, whenever you see OR, yes, there is actually a formula for that, and we'll get to it and at the end of this video. Okay, but ORs, OR makes the probability greater, right? Makes the probability greater. Okay. Because if you're talking about like one thing happening and the other thing happening as well, a combination occurring, the likelihood of that is small, right? Of 2 or more things happening at the same time. That's and, right? But when we're saying, well, either this or this can happen, that's going to increase the likelihood of occurrences. Okay, whether there's only 2 occurrences or 10 occurrences or 12 occurrences, like we're going to look at in the next example. Okay, but whenever you see or, just a good rule of thumb, the probability is going to be greater than the ands. Okay, let's see here. Read through those learning goals real quick. I'm going to pause this and we're going to start fresh with example 1. All right, guys. So for example 1, we're looking at probability day. Okay, it's a new holiday. And it's going to be celebrated at our school. It may be celebrated on any of the first 3 days of any month. The problem now is to choose which day it will fall on. Okay, and the day is going to be selected at random. So explain how many dates for probability day there are in the sample space. You may set it up like this. This isn't the only way that you can set it up. Okay, but this particular setup shows, well, there's 12 months, right? And it's either going to be scheduled on the first, second, or third day of the month. All right, so how many dates for probability day are there? 36 days, right? For question number 1, 36 days. Okay, let me back up here, get out of the way a little bit. Okay, so 36 days for number 1 on example 1. For number 2, construct a model to represent the sample space. This is it. This is the model. Okay, this is one particular model. It doesn't have to be exactly like that, but it could be. Okay, number 3, determine the probability that each day is randomly chosen. Okay, what are the chances? And again, pause yourself here if you want to think about it on your own. Okay, but what are the chances that January 3rd are chosen? January 3rd is chosen. Okay, well, January 3rd is one possibility out of 36 total. Okay, so 3A would be 1/36, right? Okay, for B, May 2nd. Okay, so we're getting rid of this guy. What's the possibility of May 2nd? Okay, well, January, February, March, April, May 2nd, that is 1 out of the 36. Okay, Part C asks, what is the possibility of any one of these specific days being chosen? Will all of these particular days all have a 1 in 36 chance of being chosen? Okay, so A, B, and C are all 1 in 36. Okay, now number 4 says, studying this sample space, let the probability of A represent the probability of randomly choosing a summer month. Okay, and what our textbook wanted was June, July, and August as our summer dates. Okay, so we're going to assume that those are our summer dates, June, July, and August. Okay, and then probability of B is going to represent the likelihood of choosing the first day of the month. Okay, so that's going to be probability of B. Again, let me make sure you guys can see all this. Okay, we're in good shape. Okay, so 4A says calculate the probability of A occurring. Okay, so what is the probability of A occurring? Okay, well, the probability of it happening in the summer months, well, there's 3 summer months, right? Out of the, how many months total in a year? 12. So 3/12 is going to be our probability of a summer month being selected. So that's 1/4 or 25%, right? Okay, now B says calculate the probability of B. Okay, so the probability of B is going to be, well, how many total options are there? 3 days, right? One, the first, the second, or the third. What is the probability of day 1 being selected, the first of the month? It's 1. Okay, just 1/3 or 33%. Okay, and then C I think is our example of an a compound event. So in this case, we want to do the probability of A and B. So basically, what this wants is, what is the probability of it being a summer month and on the first day? Well, we can look at our chart here, right? And we know that these 3 occurrences are right here, right? Summer months, first day. That's 3 out of the 36 total. 3 out of the 36 total. Okay, another way that you can check this, though, check this out. What is the probability of A? The probability of A was 3/12. Okay. And, okay, remember, and is multiplication. And B, what's the probability of B happening? 1/3. If you multiply those two, that's going to also give you 3/36. Okay, or 1/12 would also work. All right, so and is always multiplication. Once again, let me back out and make sure you guys can see this okay. Yep, okay, we're good. So whenever you see and, it's going to be multiplication. And again, we can show in the chart here in our sample space that 3 out of the 36 actually works. Okay, let's keep on pushing here. Okay, now D. D is where it gets a little bit crazy. So D says calculate the probability of A or B. Okay, I'm going to come over here and do D. Okay, this is going to be 4D over here. Okay, what is the probability of A or B? Okay, and I told you there was going to be a formula for this. Okay, but let's actually use the sample space first to make sure it makes sense. Okay, so what is the probability of it's being a summer month? Okay, well, we have all of these possibilities, right? The probability of A, the days in the, just make sure this makes sense. All the days that occur out of the 36, this would be 9 out of the 36. Now, don't freak out here. 9 out of 36 is still just 1/4. It's the same thing that we just did up here, right? The 3 out of the 12 is the same thing. Okay, so the probability of A occurring would be 9 out of 36, or 3/12, or 1/4. It all reduces to the same thing. Okay, now the probability of B, that's going to be all of these guys. Okay. Okay, now the question that we asked in class here today was, okay, well, the probability of A occurring was, just make sure that we get this right, would be 3 out of 12 or 9 out of 36, however you want to think about it. Okay, probability of A, 3 out of 12 or 9 out of 36. I'll just put 3/12. Okay, it reduces to. And the probability of B happening would be, once again, 12 out of 36 or 1/3. Okay. Now, if we were to combine these things, the 3 out of 12 and the 1/3, you would have to get a common denominator, right? So you'd have 3/12 and 1/3, which 1/3 is the same thing as 4/12. Let's see, 1/3, 4/12. Okay, let's see here. Okay, time out. Hold on. All right, sorry if that was a little confusing, guys. I told everybody who was actually in class today too that this stuff is tricky, and sometimes I kind of have to think about it too. So again, let's go back to the probability of A. We said the probability of A happening was 9 out of 36, right? Which again reduces to 1/4 still, so we're good there. Okay, now the probability of B happening, it being the first day, that is 12 out of 36. Right? So if we were to add these up, okay, 9/36 plus 12/36, that would mean that there were 21 out of 36 days, right? Okay, but what we did here was we counted these 3 days twice. And the thing with OR, when we're talking about ORs and probability, what we did here is all correct, but you have to go back and check, what did I count twice? Well, we counted these 3 days twice, right? We talked about the summer months and we talked about the first day of the month. Okay, and what we did was we counted these 3 days twice. We can't count the same day twice. So if you count all of these up, there's actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 out of 36, okay? So what we did here is we are going to subtract the 3 days that we counted twice, okay? And that is going to give us a final answer of 18 over 36. Okay, now if you go back to your notes, okay, go back to your notes and you can double check this. It is at the bottom of page 3. It says the probability of A or B occurring is equal to the probability of A plus the probability of B minus that overlap of A and B, okay, which is what we just did there. 9 over 36 plus 12 over 36 minus the overlap, the 3 out of 36, and that gives you 18 out of 36, okay, which is 50%. 50%, okay? Now for number 6, what is the probability of randomly choosing a summer month or a winter month? Okay, well, the probability of choosing a summer month, right? We already said that that was 1/3, right? Or 1/4, right? 3 out of 12. So the probability of choosing a summer month is 3 out of 12. Okay, plus the probability of choosing a winter month, 3 out of 12. But subtract out the overlap. Where do summer and winter overlap? Well, they don't, right? So you're subtracting 0/12. So that would equal 6/12 or 50%. Okay, so just another example of an OR question. And according to the OR's probability, you can use that formula down here. The probability of A or B is equal to the probability of A plus the probability of B, okay, minus the probability of A and B. All right. All right, guys, this ended up being 20 plus minutes, but this is just about as far as we got in class. I just want to set you up for example 2 so that you're prepared to start in class with us tomorrow. So example 2 is different from example 1 in that this is what's called a dependent event. Okay, now what this means is there are 6 cards total. Just think like I have 6 cards in my hands. Okay. 3 of them are yellow, yellow 1, yellow 2, and yellow 3. Okay. 2 of them are blue, blue 1 and blue 2, and then we have 1 purple card. So there's 6 total cards that I hold out to you and say, pick a card. Okay, now the chances of you pulling any one of those cards on the first hand is 1 in 6, right? Okay, but let's say that on your first draw, you drew yellow 1, right? You drew yellow 1. Okay, now the probability of you drawing the purple card changes, right? Originally, the probability of you choosing the purple card was 1 in 6. But let's just say after you draw that first card from my hand, yellow 1, the probability of drawing the purple card now changes. Okay, and the important distinction that we had to make in class today was this card does not go back into my hand. You pull this card and it is now out of my hand. Okay, now once this card is withdrawn, I'm now holding out only 5 cards to you. What is the probability of pulling the purple card now? It is now 1 in 5. Okay, so that probability changes. And I believe that's what part A is asking you. Yes. Yes, the probability changes because, well, there's less cards in my hand now. Okay, now what we left off with on in class today is we came up with our sample space. Okay, so if you want to try this on your own, I think it would be a great idea. Can you come up with a way to show all of the possibilities of drawing 2 cards from that 6-card hand? Okay, I'm holding out 6 cards to you. What are all of the possibilities that you could draw from my hand? Okay, I again encourage you to try it on your own right now. I'm going to pause it right now. All right, maybe you came up with something like this. Maybe it looked differently, but you should have come up with 30 different possibilities. Okay, again, once we draw the second card, or once we take away the first card, we're not putting it back into our hand to be drawn again. Okay, so basically what this is saying is if yellow 1 is drawn, you can secondly either draw the yellow 2, yellow 3, blue 1, blue 2, or purple, right? If yellow 2 is drawn first, the second card can either be yellow 1, yellow 2, blue 1, blue 2, or purple. If you draw yellow 3 first, it can be yellow 1, yellow 2, blue 1, blue 2, purple, and so on. So these are all of the 2-card possibilities that could occur if I have 6 cards in my hand and I hold them out to you. And this shows, okay, well, what if I draw blue 2 first? Okay, well, if I draw blue 2 first, there are 5 more possibilities for that second card. Okay, that's as far as we got in class today. You have a self-assessment and a portfolio as well. Okay, so make sure you do that the best you can, and then we'll wrap this up tomorrow in class with better internet connection, hopefully. All right, guys, I miss you. Look forward to seeing you tomorrow.